Hello, Year 9, and welcome to your first online science lesson for Knole Academy Science. So obviously, we'd like to see you in person, but unfortunately, here we are again, delivering this online. So your lessons are going to vary. You will have got an email last week telling you when your lessons are. So on Tuesdays and Fridays, you will have live Teams or Zoom lessons with Miss Callis and myself. And on Monday, Wednesday, and Thursday, you will be getting your lessons via YouTube. So, today, obviously, this is the first lesson on YouTube. And so you're going to need to have a pen and paper or a laptop where you can type your answers in. We don't expect you to be submitting your work each day to us, okay? We're going to be checking your work via quizzes that are going to be delivered on Friday on Sam Learning. So make sure you can log into Sam Learning, okay? So don't email your work to us or submit it on Edulink, okay? These are just notes for yourself. We will be checking your progress on Friday's lessons. Okay, so without further ado, we're going to jump in to the first lesson, which is rate of reaction. So the whole topic is to do with rates of reactions, but we're going to do the first lesson, which is rate of reaction. So below you see there's 4 pictures there. Can you pause this video once I finish talking and tell me what is happening to these 4 products below? And then try putting the pictures in order from the fastest to the slowest. So 1, what is happening? So you write 1, 2, 3, 4 down and tell me what is happening in each of those pictures. And then second, you need to then try and put them in order from the fastest to the slowest. If you manage to do that pretty easily, try an extension. Is a fried egg a chemical reaction? So pause the video now and have a go at those. Okay, so hopefully you've paused the video and you've had a go at those 3 questions, or at least the first 2. So here are the answers. So that picture was the firework. Picture 2, it's baking a cake. Picture 3, the nails are rusting. And 4, they're spoiled or rotting oranges, okay? And a hint there, don't ever store your fruit with apples because apples release a chemical which actually spoils other fruit and vegetables much faster. So the fastest chemical reaction is obviously fireworks. The second fastest, baking a cake. Third fastest is rusting, and 4th fastest is spoiled or rotting fruit. Okay. And yes, a fried egg is a chemical reaction. So my favorite chemical reactions are baking a cake. I mean, I love cakes. All right. If you ever bring a cake in, I am there. I'm going to eat it all. I absolutely love them. But that is a chemical reaction. All right. So if you start and you think about what you need for a cake, you need flour, sugar, eggs, maybe some vanilla if you want a vanilla cake, or chocolate if you want a chocolate cake, butter, milk, baking powder, salt. I mean, you can add a lot more or a lot less to your cakes, okay? But they're kind of just basic ingredients for a cake. But if I just handed you a bowl with all of those ingredients in, you wouldn't say that's a cake. You'd look at it and think I was insane if I just brought out this bowl filled with all of those weird and random ingredients. You'd be like, that's not a cake. I'm not eating that. And to be fair, I probably wouldn't eat that either, unless, of course, it's licking the spoon. But I wouldn't sit there and eat that. No, what needs to happen is a chemical reaction. Okay, so by putting that cake in the oven, a chemical reaction occurs, and the cake coming out is actually the product. So if you remember back to Key Stage 3 science, we have reactants and we have products. So pause the video and tell me, what are the reactants and what are the products in this chemical reaction shown on the slide here. So hopefully you've paused the video and can see what the chemical reactions are here. So the reactants are all of the ingredients over on the left side for the cake, and the product is the cake itself. So reactants and products. Okay, don't use an equal sign, use an arrow, because the arrow means reacts to form. Okay, because those ingredients don't equal a cake, they react to form a cake. So all of those ingredients react together to form a cake. So the reactants are all the ingredients we put into the cake, and the product is the cake. Okay, delicious, gorgeous cake. So a quick task for you. I'm going to give you 1 minute, so you're going to have to pause the video and give yourself 1 minute. Can you look at those pictures and write down a definition for chemical reactions? What is a definition for chemical reactions? And then as an extension, can you suggest some examples of chemical reactions that we've done in class so far? Okay, through year 7 and year 8, and also the start of this year and year 9, what are some chemical reactions you have seen or completed in class? So pause the video now, write a definition for a chemical reaction, and then suggest some examples of a chemical reaction to me. Go. Okay, hopefully you've written down a definition for a chemical reaction and some examples. So here are my examples. There are lots of them here. Okay, these are all different types of chemical reactions that we've seen in year 7 and year 8 and the start of year 9. Okay, these are the types of reactions. So a chemical reaction, you should hopefully remember, is when 2 or more substances join together to form a new substance. So a chemical reaction occurs when 2 or more substances join together to form a new substance. If you need to pause the video and correct your answer, then pause the video and correct your answer now. Okay, so those are our example types of reactions, and that is our definition of a chemical reaction. You might be going, the lesson's to do with rates of reaction. It doesn't have anything to do with chemical reactions. Well, it does, because obviously we're talking about chemical reactions with rates of reaction. We're talking about rate of reaction, which is how fast. Yes, that is Bolt, the fastest person to have existed, at least recorded, and he holds the 100-meter world record. So what do you understand by the term rate of reaction? So rates of reaction are how quickly the reactants turn into products. It's called the rate of reaction. And there's 2 ways to work out the rate of reaction. The first one is either the rate at which a reactant is used up, so all the ingredients of the cake with the reactants. So the rate of reaction is either how fast those reactants are used up, or the other way to measure the rate of reaction is to measure how fast the products are formed. So those are the 2 ways in which we measure the rate of reaction, the speed of the reaction, shall we say. So it's how quickly the reactants are turning into products. That's what the rate of reaction is. And we can either work out how fast the reactants are being used up on the left side of the chemical equation, or we can work out the rate at which the product is formed on the right side of the chemical equation. So we can measure this using the equation rate of reaction equals the amount of product produced, or you can use reactants used up, divided by time taken. So how much product is produced divided by how much time was taken to produce that product. and that's how you get rate of reaction, so how fast the reaction occurred. So, maths, oh no! Well, you're going to have to do it. We've got 3 little maths questions for you. So use the amount of product divided by the time it takes, and that will give you your rate of reaction. So divide the amount of product by the rate of reaction. Be very careful with units. Okay, so we've got grams and seconds in the first one, centimeters cubed and minutes in the second one, and then grams and seconds again in the third one. So what units do you think the answer will have? Work out the answers first. Just use those numbers. I'm going to give you a hint. All you need to do is use those numbers. Okay, it's the amount of product produced or amount of reactant used divided by the time taken for that to happen. So just divide the first number by the second, basically. So pause the video and do that now, and then as an extension, try and add a unit onto the answers, please. And the hint is they aren't all the same. Look carefully in the question for the units. Okay, so hopefully you've done those 3 maths questions. If you had a bit of trouble with the units, that's perfectly understandable. It's not easy, but my hint here with units is it's 0.82 divided by 150. So you just take the units, G dash S for the units. Grams divided by seconds, which is what you did. You did 0.82 divided by 150. So your units show that. G dash, which is divide, S, grams divided by seconds. So the second one, if you didn't get a unit, we're doing centimeter cubed divided by minutes. So it's going to be centimeter cubed divided by minutes. So 18 divided by 5 is 3.6 centimeter cubed per minute. And then the last one, if you didn't get a unit, it's going to be G dash S again. So it's going to be 0.03 grams per seconds. 2.5 divided by 75. If you didn't get those, that's okay. We'll have some more to practice on later in the week. So we can show rates of reaction on graphs. So that either the amount of product formed or the amount of reactant used up on the y-axis, and therefore on the x-axis is going to be, you guessed it, time. Okay, so this obviously denotes a fast rate of reaction, because if you look at it, if this is time on the x-axis here, the steeper the line is, the faster the amount of product formed or amount of reactant used up is. And then if it flattens, the less steep the curve, the slower the rate of reaction there. So can you pause the video and then try and draw an even faster rate of reaction for me on this graph and a slower rate of reaction on this graph. So pause the video, sketch what's on there first, so your 2 axes and the line I've got, and then can you try and draw a faster rate of reaction and then a slower rate of reaction on your graph. So that's what the slower one looks like. So it's a slower reaction because it's not as steep. And then your steeper rate of reaction should have been on the left side. So going there, almost vertical, really steep line would be a very fast rate of reaction. Okay, note we don't have any units on here yet because we're just looking at the general pattern of the graph so far. So to work out the rate of reaction again, remember, it's our formula, it's amount of product formed or amount of reactant used up divided by time. So we can do that using graphs as well. So we can calculate the rate of reaction at any point on a graph if we follow these 3 steps. So I would very strongly recommend you draw this graph right now. So pause the video and draw this graph and then write down the 3 steps as I go through them. So pause the video and draw this graph because we're going to use this as a demo graph. Or if you are writing on the PowerPoint, you can write on this graph here. So if we get a graph that looks like this and a question, what is the rate of reaction at 3 minutes? It's not as easy as just going up from 3 minutes and then reading across. Okay, it's not 32 grams per minute. Okay, we need to do something slightly different if we're looking at trying to work out what a rate of reaction is at a certain time against time. So the first step is we need to draw a tangent line. So tangent line, what you need to try and do is draw a line that matches the curve at that specific point. So you go up and you put a cross at the point you want to find out. So it asks us to find out the rate of reaction at 3 minutes. So you go up from 3 minutes and you put a cross on the line. You then draw a line that matches the curve as closely as possible. So as you can see here with this line, it matches the curve very, very closely. Basically, the curve at that point matches it. Okay, so that's step one. So you can write down step one, draw a tangent line that touches the curve at that point and matches the curve's position. Then step two, we need to draw a right angle triangle using the tangent as the longest part of the triangle. So you're basically going to draw a line down and a line directly across from the bottom and from the top. From the top, draw a line down, the bottom, draw a line across. That's now a right angle triangle. Okay, so that's a right angle triangle right there. So that's step two. We're drawing a right angle triangle, and the tangent line, that straight line we drew, is the long side, the hypotenuse. So we then need to work out basically how far along and how high our graph is. So we measure down, and so it's 4 minus 3, which is 4 minus 1, sorry, which is 3 minutes, and then convert that into seconds. So 3 times 60 is 180. And then we measure how far it's gone up. So it stops at 40 here and stops at 20 here. So 40 minus 20 is 20. So add 20 grams here. So we've got a rise of 20 and a run along of 180 seconds. We then need to do step 4, which is calculate by dividing the change in y by the change in x. So our change in y was 20 grams and our change in x was 180 seconds. So we do our calculation, 20 divided by 1, so 20 grams divided by 180 seconds equals 0.111 grams per second. So every second our equation is losing a mass of 0.111 grams. Okay. So hopefully you've got those 4 steps down. If you don't have those 4 steps down, go back, rewind the video, and get those 4 steps down, because I'm now going to give you a question to do yourselves. So you're going to try and do this rate of reaction question now. So you're going to calculate the rate of reaction at 20 seconds. So at 20 seconds here, going to go up, put an x, draw the tangent, calculate the change in y, change in x, and then divide the change in y by the change of x. So pause this video now and have a go at that question. So hopefully you've managed to calculate that now. So we're going to go through the answers. So you should put it cross at 20 seconds. You should have then drawn a tangent. So I just use the actual values because it's actually a straight line, which makes my life slightly easier. But you should have got something around 2.25 centimeters cubed per second. So 2.25 centimeters cubed per second. So 2.2. Oh, it's hard to draw with a mouse. And then centimeter cubed per second. Oh, look at that. Well done, Mr. Arrow. So 2.25 centimeters cubed per second, something around then. If you use slightly different units, you'll have a slightly different value, but it should be something around 2. Okay. So, can you try and write a conclusion based on today's lesson? What are chemical reactions? What is rate of reaction? What are reactants? What are products? And how do you calculate rate of reaction? As I said, there's no need to send the work to Miss Callis or myself. Okay, we'll be checking these on Friday and talking to you in a live lesson about it. And we will also be setting you some quizzes to see how you've done and how much you have understood. So don't email it to us. We'll be checking it on Friday. So just have it handy on Friday's lesson. Hope you've enjoyed this first lesson. As I said, welcome to your online lessons for the foreseeable future. It's good to have you here. I hope you've enjoyed it. And as always, stay safe. If you want, you can use these links to some other helpful videos.